All right. Welcome back to my channel. Don't roll your eyes at me. Hey, y'all. It is Wednesday, November 17th. Special shout out to my birthday girl today. You know who you are, right? We are still talking about fractions. It is November 17th. I want to talk about this review slide. The review slide looked really good today. Again, so I'm really happy about that. Here are our two expressions. Some of us did not read this carefully, and so had trouble in that regard. Let's read this together. Chiron says that the expressions 2 times 6/8 and 3 times 4 times 1/8 both represent the same fraction. Do you agree? What fraction do they represent? So, do you agree? Emmy?
Yes.
Yes, Emmy says yes. Do you agree with Emmy that yes, these things are equivalent?
Yep.
Yes, they are. Emmy, what is 2 times 6/8? Who else got 12/8? Very good. Our denominator is not going to change. We're doing 2 times 6 gives us 12. And we've talked a bunch of different ways. We can 2 groups of 6/8, 6/8 here, 6/8 here equals 12/8. Sorry, cactus poster, I had to draw on you today. My apologies. And Emmy, what is the value? Sorry. What is the value of the other equation? What? Yeah. Didn't you say you agree that they are the same? Yeah. 12/8 and 12/8. 3 groups of 4, groups of 1/8. We do 3 times 4 gives us 12. And then we put that 12 back to multiply the 1/8 and we get 12/8. You should have said yes, and the value of each expression should have been 12/8. Very good. All right. You have already opened up the lesson for today. You're going to need it. So here we go. Today's lesson, we are talking about problems with equal groups of fractions. I'm finding that usually when it says problems right here, it means like word problems. So we're talking about word problems and how to apply these multiplication strategies to different stories that we might encounter in our lives. So, let's solve problems with fractions, shall we?
Yes, we shall.
Decide whether each statement is true or false. So, ready? True or false? Go. Raise your hand when you have an answer. It should be on your screen too, right? You can see it on your screen. You can see it on my screen. Tell me when you have an answer. Go.
It's like just like 2 times 5, but it's just 10. It's 10, 12. It's because 5, 2 equals 10, and 2, 5 equals 10.
So is this statement true or false?
True.
Who agrees with Gage? It's true. You would be right. True it is. Ready for the next one? Go. Ooh. Go.
1 times 10 12 would be 10 12 because 1 times everything is itself. And then 5 times 2 equals 10. So, and we leave the denominator the same, so 10 12.
True or false? True. Very good. Who agrees? True or false? Oh, man. True. Okay, it's already got the next. I already hit the next one. Go ahead with the next one. True or false? Let's give everybody enough think time so that they can think themselves and see if they come up with an answer. True or false? If you think you can, you're right. If you think you can't, you probably are also right. So think you can. I can do anything I put my mind to because I'm smart like that. And I'm handsome and pretty too. Wasn't that good? True or false? Go.
Me?
Uh-huh.
It's true because 6 times 3 is 24. And
How can you prove that 6 times 3 is 24?
it's false. It's false.
Why?
Because 6 times 3 is not 24.
What is it?
6 times 4 is
No, 6 times 4 is 24. 6 times 3 is what, everyone?
18.
18. So, true or false, my friend?
False.
False. Who agrees it's false?
Yep.
Yeah, totally false. Ready for the last one?
Yeah.
Whoa! Excuse you. True or false? True. Sorry. Got a little bit of belching action. Accidental belch situation going on here. It's all right. Giggle, giggle, laugh, ha ha. We're fine. True or false? Oh. I have one hand raised at every table. So I want every table to have, I have at least one hand raised at every table. So I want you guys to have a table conversation and figure this out before we call on each other.
What's 12 plus 4?
Why?
I can count by 3.
True or false, everybody together?
True.
Because 12 times 2 is?
24.
8 times 3 is
24.
You want to teach the class?
Yeah.
You take my job?
Yeah. Yeah.
Get out of here.
as long as I get paid.
We will.
You will get paid.
All right. Raise your hand if you have followed a recipe to make something before. Anybody ever followed a recipe to make something?
Yeah.
What is in a recipe? What are some things that are in a recipe? Mackenzie? Okay. Eggs. Right then. Salt. Benny. Milk. Aubrey. Candy. So these are all ingredients, right? These are all different ingredients. What else would you find in a recipe? What else would you find in a recipe, Will?
Steps.
Good, like this first, and then this first, and then this first. You can't put the pan in the oven before you mix up the stuff and put the stuff in the pan, right? Yeah. So steps, right, Lynn?
Fractions.
Sing me the song of my people. Fractions, I love them.
Fractions.
They're wonderful. Ella.
Sugar or flour.
Okay, teaspoons, different measurements. So it might be different fractions with different measurements. Okay.
Last week, me and my dad made 230s, and it said like 3/4 of a cup of milk.
Okay.
Water.
Okay. So different fractions. That's awesome that you guys are using recipes. Super fun. Question. If a recipe is for 5 servings or 5 people, but you need more than that, what would you do? Sophia? Huh? What would you do with it? Okay. But think about it this way. Let's say you're making a cake. And the recipe says that when you make this cake is enough cake for 5 people. But you're having a party and there's going to be a bunch more than 5 people there. What would you do to the recipe? Make more. We might change it. And so we need some of this background knowledge before we get started. We often refer to the amounts specified in a recipe as one batch. So if you have 1 egg, 1 cup of milk, 1 teaspoon of salt, whatever it is, that makes 1 batch, right? What might it mean to make 2 batches of a recipe? Charles?
2 more ingredients, 2 times the ingredients.
2. Oh, y'all are making my little math heart so happy. 2 times the ingredients. Pull the paper up from the middle of your table. Look at the side where you see the loaf of bread. So you're going to look on the front. This shouldn't take a long time, and there shouldn't need to be talking, and no one needs to be the personal table passer-outer. Everybody can grab their own paper. So, and we don't need to argue about it or be unkind either, everyone. I love you very much. Let's be respectful and kind to our table mates. So, on the paper you have in front of you, you see this recipe. So, a bakery is making banana bread.
Yum.
I don't like banana bread very much. Here is the recipe for 1 batch. We need 1 banana, 2/3 cup of butter, 3 teaspoons of baking soda. You like my jokes? You like my jokes? Am I funny?
Yes.
5/8 cup of sugar, 2 large eggs, and 5 halves of a cup of all-purpose flour. All right. We're having fun, and that's great. But let's get back to business. Now, look at where it says number 1 on your paper. Let's read that together. I'll read it, you listen. I'll read it, you listen. I love you very much. The bakery makes 2 batches of banana bread on Monday. Complete the table to show how much of each ingredient is used. So, hold on now. Don't bust through this and do it without me. If we have 1 banana for each batch, but we need to make 2 batches, what would our expression be? Aiden?
2 bananas.
That's not an expression, my dude.
Huh?
That's not an expression.
It is. 2 batches.
How many batches? 2 batches. How many bananas in each?
2.
In each batch.
1.
Each batch has 1 banana. How many bananas total?
2.
2. That's how you fill out the first part of your chart. Now, what about the butter? How many batches are we making?
2.
2 batches. When we see this word each,
It's right there. Like the table. It's each ingredient.
Here it is. When we see this word each, we know that means what? Multiplication. So 2 batches. How much butter for each batch? Look at your ingredients list. Olivia? 2/3. So if we have 2/3 for 2 batches, how many thirds are we going to have all together? 4/3. I'm going to give you 2 minutes to work on this on your own. And then in 2 minutes, you're going to come together and work with your table to see how much you need to complete with your table. I'm going to be coming around. You should be working on your own right now. Okay. Finish up this table with the people with your shoulder partner. Finish it up with your shoulder partner. Talk through it. Don't just give each other the answers. Talk through it.
This is seven. Oh, because there's that 2. Oh, that's not What's 2 times 2? 4. 7. So if you add 2 to 5, it makes 7. So you get the hours. The denominator doesn't change.
Okay, so let's finish this chart together. Baking soda. What's the expression? Ella?
2 times or 2 groups of 3 halves.
What's the value?
6 halves.
Good job. Sugar? Raylan?
2 times 5/8 equals 10.
That's it. Eggs? Lila?
2 times 1 with the value.
Eggs? How many eggs are there?
2.
So I need to have 2 times
2.
2, and then how many total eggs would I have?
4.
Thank you, Lila. And flour, Bentley.
So 2 groups of 5 halves, and then if you multiply 2 and 5, then we make 10 halves.
10 halves, very good. This is what your chart should look like. Okay. On Tuesday, the bakery, oh, whoops. This should be on the back of your paper, I believe. Turn your paper over. Yep. On Tuesday, the bakery needs 8/3 cup of butter to make enough banana bread for the day. How many batches were made? So this is how much butter is in one batch, but they need their value to be 8/3. So if they're starting off with 2/3, how many batches do they need to make?
Wait up.
4
Times. Yeah, 2/3 equals.
And how did you find that out? I saw you, what you were doing. How did you do that?
I did I counted up from 2s all
So-
the way to 8.
Using 2s, because this was your numerator here. 2, but knowing you had 2 for a numerator, but you needed your numerator to get to 8, so you count up 2, 4, 6, 8. And that's 4 groups of 2/3. Good job. Okay, so based on the number of batches made on Tuesday, complete the table for each ingredient. So we already did this expression for the butter. What was the expression?
4 times 2/3.
4 groups of 2/3. That is the expression that goes there for butter. Now, if you have 4 groups of 2/3 for the butter, what's your expression going to be for bananas?
4 times 1.
Who agrees with Olivia? 4 times 1. Why? Why do you agree with Olivia, Charles?
Because 1.
Where does the 4 come from? Where does the 4 come from? Who can tell me where the 4 comes from? Where does the 4 come from? The butter tells us how many batches have to be made. So if we make 4 batches of butter, we also have to make 4 batches of all of it. All of it, right? So 4 batches of bananas. What's my expression going to be for the bananas? 4 times
1.
equals?
4.
Huh?
4.
What's my expression going to be for baking soda? Oh, you guys just want to do it on your own?
Yeah.
Go ahead. Do it to it. Go ahead and do it. This here goes in this box. Just like I had up there. That expression goes in that box. Should get a shirt like this.
What?
Multiplication expressions on it, just like that. Wouldn't that be cool?
What's the reflection? Hey, where'd it go?
And then we
Check
just,
your work. Answer keys on the board. Check your work. I give answer keys all the time so you can check your own work. There's values on there. What are you doing?
you should go to church wear every day. So if you wanted to come in the room, you can have a thing. They had to answer multiplication, got it wrong, and go to the end of the line. Miss McGinnis, I got them all right.
Good job. All right. Let's go. All right. If you have boxes left to fill, I want you to fill them in. Once both of your sections of both tables are completed, we're gonna move on. We have another activity that we want to talk about. It's a fun one. It's a fun one.
Or is it just?
So before you put your paper away, look at the side that has the bread baked on it. Look at the side that has the picture of the bread. Yeah, that's the Monday side. Look at the numerator of the values. How is the numerator changing in all of the ingredients from Monday? How is the numerator changing?
Well, I kind of see it on this side there's all 2. On this side there's all 4.
Yeah, so look at the side that has all 2s. Look at the column that says amount of ingredient. Look at the numerators in those fractions. If there's all 2s in the expression, what's happening to the fraction in each of those? The numerator.
Doing times 2.
Very good. It's going up by 2. And then, why is the denominator different in all of them?
Because it's going up every time.
The denominator? Why is the denominator always different?
There's the different fractions.
Why? Aiden?
Because the numerators are all the same.
No, you got 3. You got 2/3 and 3 halves and 5 and 5. You got all kinds of different numerators. Why is the denominator different?
Because whenever you times a fraction, you have to keep the same denominator as it is. When you first times the first fraction, you keep the denominator and then times the numerator.
Huh. I don't disagree, but that doesn't tell me why the denominators are different in all of these fractions. Why are they different? Yeah?
That's it. It's the value of all of them. Like how many there are.
What are we talking about? What is this story talking about? What is this? This whole paper is about what? Baker's baking banana bread. So who decides what the denominator needs to be? Do we know why? Do we know why he needs 2/3 cup of butter? Why isn't it 2/4? Why is the denominator for butter a 3 and the denominator for baking soda a 2? Why is that? Will?
Because it's a recipe.
Right. We don't know. He's right. It's a recipe. We don't know why the denominator is what it is. Somebody has to do a lot of research to figure out, oh, that's too much butter. Oh, that's not enough butter. Oh, Okay, 2/3 is just right. You know what I mean? We don't know why the denominator is different. Don't let that type of question trip you up. That type of question is one of the only questions I've ever asked you where the proper answer is to say, I don't know.
Really?
I didn't make the recipe. I don't know. You know what I mean? We don't know. I don't know. Why are two of the ingredients not in fraction form on the Tuesday side, on the back side? That's the front. Yeah. Why are two of the ingredients not in fraction form?
There's only bananas have to be whole, and the eggs have to be whole.
When you multiply a whole number times a whole number, you get a whole number. If you multiply a whole number times a whole number, are you going to get a fraction?
No.
No, you're going to get a whole number. And for those reasons, there are two ingredients not in fraction form. Right?
Yes.
Okay. I really like this next part. It's not on your handout, so you can just like slide that inside your Cactus notebook so it's out of the way. The bakery that sells banana bread also, what? It's so noisy. Just to put a piece of paper away is extremely noisy. The bakery that sells banana bread also sells fresh milkshakes. Okay. So initially, I probably wasn't going to go to this bakery because I don't really like banana bread. But if they have milkshakes, I'm in. Each milkshake uses 1/10 a liter of milk. That's a very important piece of information that you need to remember. 1/10 of a liter of milk for each milkshake. On Monday, the bakery sold 8 servings of milkshake. How much milk was used? Does one of these, 1, 2, 3, 4, 5, does one expression seem to represent what is happening in the situation better than others? Each serving uses 1/10 a liter of milk. On Monday, the bakery sold 8 servings of milkshakes. How much milk was used? Which equation do you like? What do you like, Bradley?
8 times 1/10.
This is the one that Bradley likes. 8 times 1/10. Michael, why do you still have your hand up?
I like 4 times 2 tenths, 8 times 1/10, and 2 times 4 tenths. They all equal the same thing.
This equals the same thing as this too?
No.
Oh, this one? Oh. And that one.
I like them all because they all equal 8 tenths.
Say that louder for the people in the back.
I like them all because they all equal 8 tenths.
She says, I like them all because they all equal 8/10. Is she right?
Yes.
She is correct. They all equal 8/10. You guys are on to me, aren't you? You guys are figuring out that a lot of times when I give you something like this, you got to check them all because sometimes they all equal 8/10, don't they?
Yes.
Yeah. Hey, so let me talk to you about this for a second. Has anybody seen these before on Freckle maybe? Yeah?
Yes.
What are these called? Who knows?
Quotation marks.
Nope. Nope. Anybody know? Parentheses. Very good. Whenever you see parentheses, you do what's in the parentheses first. So this would be 2 times 1/10. So we would write 2/10, and then we would follow up with what's outside the parentheses, and that gives us 8/10. Okay? So this is a lot like yesterday when we talked about equal equations, knowing that we have equal equations, and this equation is the same value as this one, and this one, and this one, and this one. They're all the same value, right? We talked about that yesterday. Now, let's take that a step further and match each description to an expression that represents it. So, we're going to read these 5 stories, and we're going to decide which equation over here best represents the story we're being asked. Are you ready? On Monday, the bakery sold 8 servings of milkshake. How much milk was used? Which equation best fits that story? Which equation fits it best and why? Best fit and why? Nikki. 8 times 1/10, she says. Tell me why.
Because 8 times 1/10 equals 8 tenths.
But doesn't 4 times 2/10 equal 1/10?
Yes.
Or equal 8 tenths, I mean? So why is this a better expression than this? Why is this better? Why didn't you say this originally? Why is this one better?
Because 8 times 1 is always itself.
But this is 8 tenths too. This is 8 tenths too. Ella, what do you think?
Because it doesn't have any 2 tenths or 4. It only has 8.
So what we're trying to do, we're trying to take this story and make the best match of the equation. So on Monday, the bakery sold 8 servings of a milkshake. How much milk is in each milkshake? Everybody? 1/10. That's what we have to remember. So the bakery has 8 servings. 1/10 of milk is used each time. This says 8 servings each, 1/10 in each serving. This one makes the most sense for this story. Let's go to the next one, number 2. On Tuesday, 2 customers bought 4 servings of milkshake each. So now we have 2 customers buying 4 servings of milkshake each. How much milk was used? Oh, go ahead.
2 times 4/10 equals 8.
2 times 4/10 like that?
Yeah.
Is there another one that you think? Ella?
4 times 2/10.
How does that fit the story? 2 customers bought 4 servings. If a serving is 1/10, how many servings is this? 2 servings. Does that fit our story?
No.
No. Bradley, what do you think?
4 times 2 times 1/10.
Same question. This is the serving of milk. How many servings is this? 2. How many servings is in our story? 4 servings in our story. Now? 2 times 4 times 1/10. Because now we have 4 servings and we have 4 times 1/10, which gives us 4 servings, which is 4 tenths. Very good. On Wednesday, 4 customers bought 2 servings of milkshake each. Levi?
4 times 2 tenths.
4 times 2/10.
4 times 2 times 1/10.
Does that say the same thing?
Yes.
Sure does. On Thursday, okay, so now we've used all of the equations. So now we're going to use something again, right? Right, we're going to use one again. On Thursday, 2 customers each bought a serving of milkshake. They placed the same order 3 more times for their friends that day. How much milk was used? On Thursday, 2 customers each bought a serving of milkshake. They placed the same order 3 more times for their friends that day. How much milk was used? Those of you that have your hands up, you know this is a tricky one, right? Raylyn, what do you think?
2 times 4 times 1.
2 times 4 times 1/10. Raylyn, where's the 4 come from? Says 3 right there. If I was gonna be fancy, I would circle the 3 because I go through and I circle all the numbers. Is it talking about 3? What's it talking about? Don't let me confuse you now. Don't you let me confuse you now. 2 customers each bought a serving, which is 1, right, of milkshake. They placed 3 more times for their friends. So they had how many?
4.
Yes, you were right. 2 customers bought a serving of milkshake. They placed the same order 3 more times. That's 4 servings. How much milk was used? Ella, what do you think?
2 times 4 tenths.
Could it also be, if we wanted to make it a little less, this equation here is kind of crazy. We wanted to make it a little less crazy. We could just say 2 times 4 tenths. Good, you're right. And finally, on Saturday, 4 friends each purchased a serving of milkshake for breakfast. They came back for the same thing after dinner. So 4 friends each purchased a serving of milkshake for breakfast. They came back after dinner. Olivia.
8 times 1/10.
Yeah, but they got a serving before dinner and a serving after dinner. So how many tenths is that? 2 tenths.
4 times 2 times 1/10.
Well, we have 4 friends here, right? And they get a serving before dinner and a serving after dinner. So is that 2 different servings for 1/10 each?
Yeah.
Would this one here also work for it?
Yes.
That's right. So what I want you to see in this kind of wild, crazy mess of colors over here is that the stories matter. Look here. This purple equation only has 1 story that matches. It's this one here, 8 servings of milkshake. It's the only one talking about 8. All the other ones are talking about 4. 2 customers bought 4 servings. 4 customers bought 2 servings. Do you see what I mean? What I'm trying to get you to do is see which story matches which equation, even though all of these equations equal the same value, which is 8 tenths. Very good. 8 tenths, yes?
I see that you put little thing there. Put on your mustache.
Yeah, I did. So today we matched expressions to situations. We learned that several expressions can represent the same situation, which is why some of these stories have 2 lines, right? This one goes here and this one goes. Some of these stories have 2 equations that could make it the same, right?
Yeah.
Mm-hmm.
This is your cool down. One of these will be probably your review slide tomorrow. Okay? That concludes our math class for today, guys. You did a great job. Love you so much. Well done. Have a wonderful